Well, before we jump into equations that have rational exponents, let's do one final example of a radical equation that happens to have two radicals. We've done a couple like this already, but this one might be a little bit more intensive with the algebra, and I think it'll be a good practice for us. So remember what I need to do. Isolate a radical, get it all by itself on one side, and since we're talking about square roots, we're going to square both sides. Do some arithmetic until you can get the other radical by itself on one side, and then square both sides, and we'll have an equation with no more radicals. So let's start. Radical 5 plus x. I'm going to get that all by itself by adding this radical to both sides. Equals radical 4x plus 9 minus 2. So then to get rid of this radical here, we square both sides. And remember, we have to FOIL on this on the right-hand side. So the left-hand side is easy. 5 plus x. All right, now picture radical 4x plus 9 minus 2 written out twice, side by side. And write it that way if you need to. I think it's good practice to just picture the other one there. Basically, we take this one and square it for the first, which would be 4x plus 9. That's our f. And then the o would be negative 2 times this radical, and so would the I. So we're going to double that. Multiply these two things together for negative 2 times that radical, and we get negative 4 times that radical. That's the outer and inner, and then the last is just squaring the negative 2 for plus 4. Okay, so now I want to get this term, or maybe even the entire, just the radical all by itself. So let's notice that, now maybe I'll just write it out here. 5 plus x equals. We've got 4x. I'm going to combine the 9 and the plus 4. 9 plus 4 is 13, minus 4 times a radical, 4x plus 9. Now I want to get rid of these two. So I'm going to subtract 13 from both sides, and I want to subtract a 4x from both sides. Then that will get all by itself on the right-hand side, negative 4 times 4x plus 9 under the radical. What do we get on the left? We get the x's add up to negative 3x's. I'll put them first. I'm not lining them up the same here. And a 5 and a negative 13 would be a negative 8. And once again, if you want, we could divide everything by 4 to get the radical all by itself. But when you have a radical just times a number, if you want, you can just leave it and square it. And I think I prefer that because I don't mind dividing negative 8 by negative 4, but I don't want to divide negative 3x by negative 4, getting a fraction. It just might make it a little bit more work. So I think I'm going to square both sides right now. All right, and on the left-hand side, that means we have to FOIL. So negative 3x squared is going to be 9x squared. That's the f from the FOIL. And then the o plus I, I'm going to put those together. The o would be negative 8 times negative 3x, which is positive 24x. But outer and inner would both be positive 24x. So 24 and 24 is 48x. That's the outer plus inner. And then the last is going to be negative 8 squared, which is 64. FOIL. And when we square this, we're going to get negative 4 squared is 16. And then this squared is just 4x plus 9. So don't forget, when you multiply two things that are multiplied together, there's a negative 4 times this radical. When you square that product, you have to square them both. It's this squared for 16 times this squared for 4x plus 9. All right, let's see what we get now. Let's just, let's multiply this out. 16 times 4, 16, 32, 64x. 16 times 9 is, I believe, 144. Okay, so maybe I'll put a line through that because I simplified this, distributed it, to get this. Now I'm going to subtract. I'm going to do minus 64x. Now let me write it out. 9x squared plus 48x plus 64 equals 64x plus 144. I want to get 0 on one side. Now all we have is a polynomial equation. So I'm going to do minus 144 on both sides. And I'm going to do minus 64x on both sides, giving me 9x squared. 48. This would be minus 16x. And what do we get here? It would be an 80, negative 80. A negative 144 plus 64, looks like that would be negative 80, equals 0. And unfortunately, we can't factor this in our heads. I think I'm just going to do, I may regret this, the quadratic formula. So we have A equals 9, B equals negative 16, C equals negative 80. All right. So the quadratic formula tells us, let me write it up here, x equals negative b plus or minus radical b squared minus 4ac all over 2a. So that's going to give us, negative b is 16. Plus or minus b squared. Negative 16 squared is, negative 16 squared is 256. So I got to put the big radical. 256 minus 4 times a, which is 9, times c, oh boy, which is negative 80. Goodness. All over 2a, which is 2 times 9. Should be 18. All right. This is equal to, I'm going to break it into two fractions as I frequently do. And underneath that radical, I may have to find my calculator here. All right, it's going to be, this is going to be 256 plus, because it's a negative and a negative, 36 times 80, and that will give us 2624. Wait, let me make sure I did that right. 36 is 9 times 4 times 80 plus, I think I did subtraction last time, plus 256. That would be 3136. All right, so this is equal to, reducing it would be 8 over 9. And then, all right, I need to mess around with 3136. 3136. guess I could pull out just a 2, which would be 1568, and another 2, that would be 750 plus 34, 784, and another 2, which would be 350 plus 42 is 392, and another 2, which would be, let's see, 380 would be 190, it's 196, and another 2. I'm having to completely factor 3136. 196 would be 2 times 98. 98 would be 2 times 49. Okay, so what that tells me is that 3136 is equal to 1, 2, 3, 4, 5, 6 times 49. It is equal to 8 squared. 8 times 7 is 56 squared. Now let me just double check that. I probably should have just used my calculator to begin with. If I took 56 and squared it, I get 3136. Okay, so plus or minus radical 3136. I wish I would have just plugged it in. I didn't think it would be a perfect square, but it is. Turns out to be 56 over 18. And actually, 18 times, let's see, 18 times 3 would be 54. So let's see, we can get 8 over 9. Dividing it by 2 would give us 28 over 9. I just divided 56 and 18 by 2. So I think we're about there. Final answer coming up. Let's see, it is 8 over, it's 8 minus 28 over 9, which is negative 20 over 9. And it's 8 plus 28. 28 and 8 is 36. 36 over 9 is 4. So x is equal to 4 and negative 20 over 9. All right, long problem, and we haven't plugged it in yet to see if they actually work. I think I'm going to leave that for you to do. You should plug in a 4, which that would be pretty easy to plug in. And then negative 29 would be a little bit tougher. So I'm going to leave this as the solution, but make a note that I did not check. I did not plug both of them in to make sure that they work in the original equation. Wow, that took much longer than I expected to. Well, now let's dive into at least a very brief introduction to rational exponents. And all we mean by rational exponents are fractional exponents, like w to the m over n, where m and n are nice whole numbers or integers. So just to warm us up, let's write this as a radical. Well, here's what you want to remember. When you have w to the m over n, the top one is the power, or the exponent, and the bottom one, the denominator, is the root. That's really all there is to it. So if I want to write this as a radical, I'm going to write w, and the power is m, and the root is the nth root. So this is equivalent to this. One of them written with rational exponents, one of them written with a radical. Now I'm going to show you there's one more way you can do it. Notice what I did. I took w and raised it to the power, and then took the root I could also have done it in the other order. I could have said W, take the nth root, and then raise the whole thing to the power. These will give you exactly the same result. It doesn't matter if you do the exponent first and then take the root of it, or if you take the nth root of it and then raise it to the mth power. So for the second one is just a real simple one. What is the power and what is the root? 4 is the power, the exponent. 3 is the root. So that's simply going to be equal to y raised to the 4 over 3 power. So these, that is equal to this. This is the rational exponent. 3, the denominator, is the root, and the 4 is the exponent or power, as you can see. Well, hopefully you remember your rules of exponents. And the generic one, I think, would be something like, let me say, r to the s, all of that raised to the t is equal to r to the st. So you multiply the two exponents. When it's an expression raised to an exponent and the whole thing is raised to another exponent, you can rewrite it as the expression r, in this case, raised to the s times t. So that means that a to the m over n could be written as a to the 1 over n, in parentheses, raised to the m. Right? Because 1 over n times m, or m over 1, is m over n. And the other way to do it would be to take the a and first raise it to the m power, and then raise it to the 1 over n. Because m times 1 over n is m over n. So it doesn't matter if, remember, this is like the root. Take the nth root of a and raise it to the m power. Or you can take the m power of a and then raise the whole thing to the nth root. All right, well, before we kind of give a recipe in the next video, let's just watch how we solve this. It says solve this equation using rational exponents instead of the radical. So I'll write it first, which would be 6 x to the what exponent? Let's see, it'd be 3 over 2. Because it's the square root, the second root, which is what we have here. You know, we leave off that 2 there. And the exponent is 3, so it's 3 over 2 minus 48 equals 0. So then, what we want to do is get the, and we'll see this in the next video, we want to get the x to the 3 over 2 all by itself on one side. So 6x to the 3 over 2 equals 48. What did I do there? I just added 48 to both sides. And now I'm going to divide both sides by 6 to get the x to the 3 halves all by itself. That cancels. X to the 3 over 2 equals 48 over 6 is 8. So this equation is equivalent to what we started with, only simplified greatly and using rational exponents. And let me write it up here. X to the 3 over 2 equals 8. Now, see if this makes sense based upon what we did up here and here. I'm going to raise both sides to an exponent that will get me x all by itself. What do I multiply 3 over 2 by to get a 1? Because I'd like to have x to the 1 power. The reciprocal, 3 over 2, raise it to the 2 over 3. But if I do it to the left-hand side, I also have to do it to the right-hand side. So now, this left-hand side, 3 over 2 times 2 over 3, everything cancels, and you get x to the 1, which is just x, equals 8 to the 2/3. That's the correct answer, but it can be simplified. Let's note that we can write this. I like to write it using radicals in order to simplify it. This is equal to, there's the radical, there's the 8. Now, what's the root? It's the cube root, and then the exponent, it's squared. So I can either put 8 squared, or I can put the squared completely outside. I find it easier usually to do it this way. You get the same number. We know the cube root of 8. It's 2 squared. Cube root of 8 is 2 squared, so we get x is equal to 4. All right, now we'll go through the recipe on exactly how to do that with all rational exponent equations in the next video.